All right, ladies and gentlemen, go ahead and do your entrance ticket. We're going to grade it together on the next slide. So go ahead and do your entrance ticket and pause this and write today's objective on your paper. Okay, pause the video while you do your entrance ticket. All right, now let's grade your entrance ticket. We're going to make this one, since it's towards the end of this, worth 8 points. Okay, 8 points. This top is worth 2, or not 2, 1. Bottom is worth 1. Top is worth 1. Bottom is worth 1. If the whole top isn't right, you don't get any points. If the whole bottom isn't right, you don't get any points. Okay, 1, 1, 1, 1. Minus however many, and then your score out of 8. Please circle it, put at the top of your paper. Whoever your assigned turn-in person is will grab those and put your score on top of your paper and turn it at whoever's in charge of making sure your turn-in bin's organized. Please grab these and make sure they are turned in. All right, next thing we're going to do today. Today's objective, you should have already written it down, but if you haven't, go ahead and pause the video and write it down. Today's objective, I can use exponents with whole number bases instead of variables. So we've been doing stuff like x2 times x to the 4th, right? Those are variables as our bases. So today we're going to use numbers as bases. So let's go look at number 2. Okay, there's nothing really different about this. If this was x squared times x squared over x to the 4th, what would you do? Well, the first thing you could do, you can combine these up here, and you get x to the 4th over x to the 4th. Same thing here. I get 2 to the 4th over 2 to the 4th. So what is the answer to that? It's 1, the same as it would be if I had x's, okay? Because something to the 4th, oops, sorry guys, cancels with something to the 4th. Base 2 to the 4th divided by 2 to the 4th, okay? That's not always going to happen. You're not always going to get a whole number. That's not typical, which is why I picked this one, because sometimes you're going to get just a 1 or a 6. If you had 2 squared as your answer, I would want you to put 4. You know that's 4, okay? All right, so now we're going to do one that's more complicated. Go to number 3. First thing I always do is this always becomes 1 to the negative 3. Well, here, let's do it the other way. See how you guys like that. All right, first, 2 to the 0 to the negative 3. What does that become on the bottom there? Becomes 2 to the 0, because 0 times negative 3 equals 0, right? So 2 to the 0. Up here, I'm going to distribute this 3. We know if there's no exponent, just like a variable, it's 2 to the 1 times 3, because parentheses means times, 2 to the negative 4 times negative 3 is negative 12. And all of that is to the 3rd. So let's see what all we can start simplifying. Okay, let me grab a different color here. 2 to the 0, that's all 1. We don't really need any of that anymore. Okay, let's not keep stuff we don't need. Let's simplify what's inside. This negative 12, where can that go? Down. 2 to the 3rd over 2 to the 12th, and do not forget these. That's what I see people do all the time. They forget that outside exponent, because when you're doing exponents and you've got all these parentheses, you have to work your way from the inside out. So I want you to make sure you don't forget that outside exponent. If you're going to forget it, distribute it first thing. Okay? Once again, steps on here can change, and that's okay. So let's simplify. If I have 3 and 12, what do I really have? 2 to the 9th, but is it on the bottom or the top? Which one's bigger? The bottom. But then if I have nothing up here, I need to put a 1. Okay? Still have my 3. It didn't go anywhere. So let's go ahead and distribute the 3. 1 to the third over, and parentheses means a multiply. 9 times 3 is 27. I can still simplify this more. 1 to the third. What is 1 to the third? 1. Do not say 3. 1 times 1 times 1 is 1. 2 to the 27th. You do not need to simplify 2 to the 27th. First of all, that's a big number. Second of all, I only want you to simplify things that are like 2 squared or down. Okay? 2 squared, 2 to the first, 2 to the 0. Okay? Those things you can simplify and make a number. You really don't need to with other things. Okay? Because what I'm trying to get you to learn is how the exponents behave the same no matter what the base is. As long as the base is the same, which here it is 2, 2, and 2, everything behaves the same as what we've done with our x's and our y's and our z's. Okay? That's really what I want you to see, not so much the numbers. So let's look at number 9. Do I have the same bases? I do not have the same bases. So now I have to figure out what I'm going to do. I can do one of two things. I'm going to do this both ways. First way, what is 2 squared really? It's really 4, right? And if I don't have an exponent, it's 4 to the 1. So I could make this 4 to the third over 4 to the 1, which we would know. Now I've got the same bases, so I can do 3 minus 1 is 2, 4 squared, and I can make, well, we know what this is, 16. Another way to do this, if I didn't have this in a way I could convert to 4, can I convert this to 2's? Yeah. Remember when we did our factor tree? 2 and 2. So 4 is really 2 squared. But I have that to the third power over 2 squared. So let me rephrase that and articulate it again because that was a little bit much to process, right? I turned 4 to the third, I turned the 4 into 2 and 2, right? 2 and 2. And then I kept my third exponent, so 2 squared to the third. So all I did was rewrite this 4 as 2 squared. Now I can distribute that 2 to the 6th over 2 squared. Okay, do I have the same base now? 2 and 2. Yes, I can simplify 2 to the 4th, which is not 8. It's 2 times 2 times 2 times 2, 4, 8, 16. Okay, either one of these would be considered correct. But before you can do them, you have to get the same base. So make sure you put that in your paper somewhere. Must have same base. Okay, cannot change the base, must be the same base every time, all the time. All right, here's another one. We don't have the same base, but this is 1, right? Like, I don't need that. So I really have 4 to the negative 4 over 1. If I move this 4 to the negative 4 to the bottom where it really belongs, and I've got a times 1, don't really need that. And I could put a 1 up here because remember, 1 doesn't change anything. I can leave my answer as 1 over 4 to the 4th. Okay? Some of my answer keys are going to say things like 1 over 2 to the 8th because they converted this all to 2's, right? They made this 2 squared, because that's really what 4 is, 2 squared to the negative 4th over 2 to the 0. And right now I'm just redoing the problem. I'm just doing it a different way. Here's one way. Here's another way. Over 2 to the 0. I can move my 2 to the negative 8th down. 2 to the 8th. I don't really need 2 to the 0. right? It's just gone. Or we can make it a 1. So I can rewrite this as 1 over 2 to the 8th. Now, if you get 1 over 4 to the 4th and you're like, oh, I might not have done this right, put on your calculator. 4 times 4 times 4 times 4, does that equal 2 to the 8th? Which is 2 times 2 times 2 times 2 times 2, 8 times, okay? Not 2 times 8, it's not 16. 2 to the 8th power. That is different. Okay, so if your answer key doesn't exactly match what I have, check it and actually do the math, like put it out and see if it works. All right, let's go to number 18. Let's get rid of that 2 to the 0. We don't need it. On the top, I've got 2 to the 3rd and 2 to the 4th, no parentheses, which means this is an add the exponents. 2 to the 7th. You do not need to simplify that. Like, don't plug it into your calculator, just leave it as 2 to the 7th. Okay, I want to know that you know that as long as these bases are the same and there's no parentheses, you add. That's what I want to know. I don't want to know, can you plug it into your calculator? I hope you can. All right, let's start simplifying number 19. First things first, this is 2 to the 1. So I have 2 to the 4. Let's move this -1 down. I don't like negatives. You know how I feel about negatives. 2 to the 4th over 2 to the 1 that was already there, and another 2 to the 1. And do not forget your exponents outside. Do not forget them. If you do, it makes the whole problem wrong. So make sure you really focus on those ones outside. If you're not going to do them, or you forget them, distribute it first. Okay? So on the bottom, I have 2 squared. On the top, I have 2 to the 4th. I got that 2 squared by saying 1 plus 1. So let's simplify what I've got. Oh, I almost forgot my -2. 4 minus 2 is 2 squared. And it's on top because 4 is bigger than 2 to the -2. I can distribute that. 2 to the -4th, but I cannot leave that, right? I need to move that down. I can't have negative exponents. 2 to the 4th. 1 over 2 to the 4th. And if you check the answer key, it's going to say that that's right. Okay? Oh, goodness. All right, 30. This, when I distribute, becomes what? 2 squared stays. 2 to the 0, what's 0 times -4? Just 0 over 2 to the 3rd. I can get rid of that because it's just a 1. 2 minus 3 is 2 to the 1, and it goes on the bottom because 3 is bigger than 2. 1 over 2 to the 1, which is the same as 1/2. Okay? Check your answer keys if you're stuck. Oh, I love this problem. I think we did number 9 like this a couple of days ago. What happens when everything's to a 0? You don't need to distribute. You don't need to do any math. This 0 means the whole answer is 1. You don't have to do anything because 0 exponent to everything means all of these become 2 to the 0, which means 1. We're done. All right. If you're getting this, feel free to go on and finish. If not, I'm going to do another video with 2 more examples on it. So go ahead and work ahead. If you're done, feel free to finish. It should not take you, this video is 14 minutes or so. It should not take you the whole hour because I've done like, I don't know, probably 8 of these problems. We could check. 1, 2, 3, 4, 5, 6, 7, 8. I've done 8 of them, and there are 30, 22. That leaves you 22 for the whole class period. You can finish them all. Okay? Finish them all, please. Answer key is in the book where it belongs. I will also put answers on the last page of the next video. Okay, so go ahead and work through if you've got it. If not, we're going to put on another video with 2 more examples.